Hello and welcome back to 5-Minute Materials. Today we're going to be looking at Noise the Node. It's Noise the Node the movie. So we are going to jump straight in to our session, and you'll see we have some models set up here. Let's jump into the material that they are all using. And first thing we're going to do is we are going to search noise. Now, you'll see that this isn't like a texture sample, right? It's not a texture sample of noise. And we're going to get into why this may be more preferable to this in this video. So let's just go ahead and plug noise straight into our base color. And you'll see it's very small. It's very small. It's a small bean. Now, if we click on this, we can change the scale in the noise node. The other thing we could do is we could actually, with its position, use world position or any kind of UV thing. I believe this can be, 2 or 3 dimensional, and it will just kind of figure its shit out. But if we just chuck that bad boy in there, and then we can scale using a multiplicative of the world position. So if we, do this and blah, 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 blah. So what is this node actually doing? Well, depending on which function you are using, it may or may not be using internal textures, or it can be completely computational. Now, you will notice when we do change each mode, the instruction count changes. Now, I always preach that instruction count, very unreliable metric, but in this case, you can kind of just see which one's doing more shit. Now, why are we going to use this over textures? Well, this has the capability of being a 3-dimensional noise. So if we go to fast gradient 3D texture, we can also change the amount of levels that it has. So this is like how many octaves of noise are being generated or shown or whatever. Rule of thumb, the less levels you have, the cheaper the cost is. You can also change the output range. So if I wanted this to be 0 to 1 instead of -1 to 1, which is why this was so contrasty before. You can also, again, do that after the noise, control however you like. There's also the level scale, which is going to change the scale of each subsequent level. So if this was set to 1, it would just be overlaying the same noise over itself. Whereas if this was, 1.5, it's going to offset each noise level by this value. And then last but not least, there's this turbulence button. Usually I like to have this off because it's just wacky as hell when it's turned on. So we're just going to switch that off for now. And you can see we have this nice little noise pattern. Now, why is this, again, useful compared to texture noise? Well, if we actually look at this in the world, then we'll be able to see that this is actually a 3-dimensional noise. You can see that there's a little pocket of darkness. Let's look at this one, for example. As we move up and down, we are kind of seeing a slice of that dark spot. If we went over here, then we would see that dark spot from this angle. Probably better to look at from this side. There we go. That's that dark spot. What this really means is that this noise function can function entirely independently of the UVs of whatever the object is. So for things like spheres that are almost like impossible to skin properly, this would work perfectly. It works across UV seams. It's just good. Let's look at a variation of this. It is called noise 3D. No, sorry, vector noise. You'll see that it is kind of the same but different. And this is basically just 3 of these overlaid on top of one another. Now, I'm not sure what would be more computationally expensive. This one doesn't have as many options for remapping stuff. However, we can remap it after the fact. So let's +1 divide by 2. That's going to remap our -1 to 1 to 0 to 1. The reason this is handy is that you can just break out all 3 channels and use them as 3 different noises that don't kind of overlap with one another. So let's look at a few examples of how this can be very handy. So as you can see here, I have a character model. Let's actually just look at this if we were using a noise texture. So if we grab my cloud noise, then you can see here that the noise is different depending on the UVs. And you can also see, you know, for each of these bits of the gauntlet, it kind of doesn't tile or anything. Things that are UV'd, you know, they take up more UV space. The texture is smaller, and things that are smaller in UV space have bigger texture. You can also see that, for example, here, where the UVs have a seam down the middle, this noise doesn't carry over. If we just switch back to our 3D noise, then you can see here that it is more consistent across the gauntlets, obviously because they are slightly offset. We don't get perfect tiling. But then, for example, up here at the top of the hood, we don't get any seams. Now, we could be using this for a bunch of different things. We could, you know, have our character who can be some color, and we will grab a dirt normal. I'll probably skip most of this in editing. So I did a little bit of off-camera mining, and this is what we've ended up with. And it's just a height lerp using the noise as the driving value. I forget what it's actually called. Height lerping between a kind of rocky normal. We're also using its height map in this height lerp. So this is our character. They're now caked in mud, or maybe they've been like stonified. But you can see that this carries across our UV seams to some extent. Obviously, this texture is, you know, being skinned onto them, but the actual like transition values are in world space. So another thing that I use this kind of 3D noise for is for our rain effects. So if I go to scalar parameters and we turn the wetness up, and then we will turn the rain value up, then you can see we kind of get this like pitter patter of rain. However, when we look down here, you can see that the rain is, you know, going downwards. Now you might think, oh, this is like a tri-planar, blah, 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 blah. But this is just a simple one-dimensional, well, one-channel 3D noise. So what's actually happening here is that the noise is moving downwards in world space, just using time and, you know, subtracting from the Z in world space, which gives the effect of, you know, when it's on top, it's just cycling through all the noise. But when you look at it from the side, you can see it kind of dripping downwards. So there's actually no masking going on here. It's just a descending noise pattern, which I think looks pretty fantastic. It's also hella cheap. So if we look, for example, here, rather than moving the texture, you know, up and down, we're going to move the object through world space. And you can see on the top, it kind of just looks like random noise is happening. But on the sides, you can see that, you know, because they're facing straight up, it's like they're dripping down. So that's a nice little use of noise that I've come up with. Obviously, this is on an angle. You kind of get a half-half. So you still get the direction that it, you know, it's moving down, but you also get a bit of like extra noise. So yeah, that is noise. That's the noise node in Unreal. 3D noise, pretty good. As always, if you did learn something new or you just enjoyed the video today, make sure you leave a subscription and press the comment button. If you do want to support these tutorials, you can do so for as little as $1 per month through the Patreon, which is in the description below. And if you have any questions about Unreal Engine or any of these tutorials or any other stuff, join our partnered Discord, which is also in the description. So I guess with that, we say goodbye. Goodbye.